Check. Testing. All right. Okay, so we're going to go and try and do a build in one night. It's going to be a simple project, and I'm going to answer any questions you have as we go. I'm going to try to explain the whys as well as the hows, and we're going to give this a shot. I did a format similar to this the other day, where I thought I was going to kind of make a game people were telling me to do. I ended up making my own little one night mini game, and I thought, you know what, this is a good format for people. The goal is to go through the game process from beginning to end, which could include anything like shaders or physics or packaging trouble. Because I've just noticed a severe, in tutorials, a severe lack of just things. Let's see. Should I add my webcam? I probably should have done that beforehand. Let me see if I can add. I will add my webcam another day because live is not a good time to mess with that. See if I already had done it before. You know what? Let's see. Well, did that add it? Okay. Anyway, let's just go ahead and get started. So all I've got Unreal 5.5 open, and we're gonna open a blank project, and we're gonna call this peg machine. We're gonna make a peg machine that falls down the pegs and makes score. We're gonna do a little bit of a light UI, just make a basic game, and I'm gonna show you everything we got to do that. So right now, my primary project is interesting. I've not seen that error before. Um, so my primary project is a game that I'm working with third party studios on called Ages of Kataria. Um, if you look up the footage right now, they're in the process of updating it. We've got a lot of gameplay built. A lot of the stuff being advertised is kind of concept advertising, but the game we're going to be launching in September for early access. And I'm gonna have some more information about that on my channel soon too. Some videos that kind of highlight some of the fun stuff we're doing. But that's what I've been doing as my day job. I've been working in the Unreal Engine for quite some time now, what, 5, 6 years, and I've been doing in IT in general for about 11 now. So that's just what I do. I've been in tech and video games for a long time. I used to do a lot of work, and I still work with them some. But I used to be a lead developer with another reality studio where we do a lot of projects for companies like training simulations, a lot of VR stuff, like a lot. Apps, iOS apps, Android apps. Some things that I don't mention a lot about the projects because a lot of them are NDA, some of them are secrets. So it's like I've done some really cool stuff. Like we've made a VR story simulation game where it had multiple endings and characters, and it had hand actions and stuff. A lot of fun things. And that was a big game, and several people worked on it. A lot of good work from other people as well. Really fun systems and animation systems. We built our own engine to drive it, really, not engine, mission manager. Yeah, we always do custom mission managers and stuff. Whenever you use someone else's, it's just a mess. It's never built for what you actually need. But yeah, so I've done a lot of different things, and what I want to do is just start sharing with you. So one thing I had wished I had done before I got started was compile the shaders. I thought it'd be cool to open up the project together, but as I did that, I realized that I should have compiled the shaders beforehand. So next time I'll have the shaders compiled. Live and learn. You can see I don't have a UI. I'm not using Linux. I'm using Windows, but I have a custom version of not version. I have a shell, my own shell I've made. It's called Adam's Launcher. All this is just a little launcher that opens. Like if I have this over here, you'll see it when it opens. It just opens what I want it to open and nothing else. It doesn't run ads or show me the weather or anything else. So essentially, I just close the shell that Windows likes to use, and I open my own shell, which is still in progress. But it just runs what I want it to run and nothing else. I would like it to do a few more things. It's not quite there yet, but I think it makes Windows run a little faster, and I think it makes it crash a little less because Windows runs a lot of services in the background and things it doesn't need to, and Task Manager is one of the stupidest, craziest ones. It just not the Task Manager, but the Windows taskbar is way too busy. It's way too busy. So if you just don't launch it, you just launch your own shell, it's better. Well, I guess I can fool around with getting my camera to work now since we're waiting on shaders. If you've got a question at all about Unreal, you can ask me, and while we're waiting to get started. If you can't hang around the whole time, that's all right. This is gonna stay up. Depending on how it goes, I'm thinking about doing a recut for like a consolidated video later. But I'm not exactly sure. It's gonna be a lot of time. I might, if I do a recut, it's probably gonna be mostly the exact same thing, just maybe some of the stuff like the compiling shaders cut out. Let's see. So I can show you a sneak peek of Ages of Kataria. Probably shouldn't, but so you got to understand the copy I'm running is we have a very like devved up version going right now with a lot of different things we're testing. So this is not the kind of polish you'd see in the game, but I'm just prototyping a new feature where you have more direct control over the villagers, and I think I like it a lot. So I'm just loading up here, but I'll show you kind of the feature I was working on. I'm trying to get them to harvest resources multiple at a time. So I'm checking if he'll go harvest that tree, and he does. Gets his little axe in his hand. She harvested that rock and ran off. We'll be live streaming this game actually tomorrow night. But you may or may not see this in the build, but that was working as expected for the most part. Needs some visual flourishes. Some logic's got to be done on the trees afterwards. We have the logic completed on the trees when it's done through the job associated with the building, but we decided to focus some more on individual labors for the beginning of the game. So we're kind of adding some features. Really feel pretty natural to it, but they don't have some of the polish that you would have, like some of the stops and starts you would have. So, oh man, I really should have compiled shaders first, huh? All right. I'll put a link to Kataria in the description as well. So I had this jazz song on my little demo reel here, but I had to mute it because the last time I played it, it was it's supposed to be rights free, but it still got copyright struck. So I was pretty upset about that. That was a fun app. Um, that's one where we did a AstroTurf prototype for a company that sells AstroTurf. Hang on. Yeah, I left it. That was a game jam game I made on this channel. That one was fun. That's actually that's one of the things that kind of inspired this thing. I love the physics on those cards. I had a great time playing that game. It did okay in the game jam. And let me know in the comments if anyone's going to be doing Mark Brown's game jam this weekend. I probably don't have the time. Oh, that's when we made dinosaurs walk around this big tree. That's just these are just VR apps I've made. The baseball one actually, it's my most popular little app I've made. I've got like 50 something downloads and people ask about it all the time. It was just for Oculus. I tried to make it for Quest later. Quest wasn't really popular yet. It was around, but it wasn't popular when I made the baseball app. And when I started making Quest apps for the Quest 2, there was a huge learning curve that came with it. So by the time I came back around and actually knew what I was doing to build the baseball app on not PC VR but actual Quest, those files, Quest moves really fast. It's got a lot of different plugins and things, a lot of dependencies, including Android versions. It's got to be in everything. And so getting that project updated to be work on the Quest 2/Quest 3 was not possible. Like I was looking at it and it was just essentially way easier to just start from scratch and build a brand new baseball game. Which I might do one day. Maybe it'll be one of the one night streams. Yep, next time I'll have the shaders precompiled. We'll start right with it open. But we're getting there. As soon as it gets done with these shaders, it'll pop right up. See if I can get that camera going. go. Put me in the corner here. I wonder if I can put a mask on it. Let's see. It's an audio filter. I'll put a comment kind of where some of the pre-stream buffer stuff ends. Getting old sucks. Start losing your hair. Let's see. We're almost ready. I should have started compiling shaders first, but I didn't. Turn it this way a little bit. There we go. There we go. It's a little better. A little smaller, though. I don't need to be that huge. Wish there was... Oh, cool. Oh, that's awesome. I like that. You just can't see me in the corner there, but you can see me right here. Let's see. Um, if we just do add, I would make it a little bit see-through. Multiply might work. That way you can kind of see both me and do that. There we go. It's kind of the... Unless we're doing some business over there. All right, here we go. Finally. So first thing we're going to do is create a new level. I'm going to talk as if you've opened Unreal a couple of times before, at least. I can't be doing the very, very basics, or we won't be able to get through it in a night. So kind of if you started some projects, never really got very far, we are making a peg machine. So it's going to start at the top, fall down, and go into a different slot that has a different point value. We're going to add up those points on a widget and kind of make it open and close and package and see what else fun things we can do. We might do colors. We might do... we're definitely going to do a little bit of physics, some spawning actors. So we're going to do... we're going to see what time allows, but we're definitely going to make the basic peg machine tonight. So let's see. Thanks for joining me, by the way. So I've just been in Unreal Engine 4 a whole lot, working on a different game. So I'm always got a little bit of jet lag when I jump back to 5. We're going to start with an empty level. The reason we don't go with world is because everyone's going to have varying skill sets that might watch this. So I'm going to be explaining everything I do with kind of a general sense. So the reason we don't go with open world is because these are huge levels that have a lot of different priorities on how space and everything works with them. We just need a basic level for something like this, really basic. So we're going to create an empty level, and now we've got nothing. So the first thing we can do is just change our lit mode to unlit here in the corner. So now we can see everything we're doing without necessarily have to worry about lighting right away. So if we open our content drawer, one of the first things I like to do is create a new folder and just name it after the project. And the reason you do that is because when you import other plugins and things like that, or asset packs, they will have their own name in this main folder here, and you will have your stuff littered against their stuff, and it's going to get messy. So if you have all of your stuff in its own folder, then you can bring in other things without having problems like that. But for a game this small, we're not really going to make a ton of folders. I might make one for, let's make one for blueprints. Let's make one for materials. And we'll start with basic blueprints. So first thing we're going to do is we're going to make the actual peg machine. And we're just going to make an actor. We're going to name it peg machine EP. And we're going to double click that to open it up. And here we're going to just bring in some basic geometric shapes. So these are called static meshes. When you hit add components, everything you do, everything that is like an object inside of this object, because all blueprints are, they're just a game object, something that can be spawned multiple times. It's a little bit like a prefab in Unity, but object-oriented programming is how Unreal works, like, period. It is very object-oriented. So an actor is really an actor is just an instance of something, and a blueprint is just usually like a way to build an actor. So once you have an actor, like we just have a basic actor that has nothing in it, no code, I can drag this into the level here, and now we've instanced an actor in the level. So this exists in the level as is. If I hit play, you see nothing because nothing's happening. There's no logic. There's no anything. We just got an actor in a level, but that actor is in the level. So when we hit play, we will see what it does. So let's go ahead and add some static meshes. Now we need cube, plane, and sphere. These are like pre-done primitives. So they're essentially a static mesh, but they're a primitive, and they have very basic polygons and stuff. We're just going to do a static mesh, and we're going to call this the background. When we select it here, we're going to look through these pre-done static meshes here, and we're going to just get, there's a lot of things we could pick from, but let's just go with a cube. I just want a cube. Here we go. Here's a cube. That's different than the primitive cube, because this is something we can swap the mesh on later. So I'm going to angle this how I want it, but first, so I'm going to go perspective because I'm going to make all this kind of flat. This is going to be the back wall of the machine that the pegs drop through. So I'm going to go to a top perspective, and I'm going to see how I'm angling this. When I click this button right here, this lets me angle things. If I'm ever moving too fast, you can just let me know. And I'm going to scoot it back some because I don't want it right on my plane there. I want it back a little bit. And then I'm going to go to the front perspective. I'm gonna center that up here, and then I'm going to hit the scale object, and we're gonna make this a lot bigger. But I don't usually like to do it right here in the editor. I usually like to come over here. And we're going to make that 10. Leave X10. Let me go to the top. Yeah. Okay. And so now we've got kind of a wall. And I'm going to make this thinner. I'm going to make it 0.2. Now if I go back to perspective, we've got a background here. This still really isn't big enough, but I just kind of wanted to get a gist of where I was going before I exploded it up. Let's go 50 and 50. There we go. Now that's a good back wall. So one of the reasons you can do it like this, if you prototype it and you have a background here, let's say you get your own mesh in Blender, you make your own beautiful divoted background or whatever that's actually a static mesh. This could be a plane or a picture and stuff too, but right now I'm just going with a geometric shape, an actual mesh. If you do it this way, when you prototype it, you can actually bring in your own, like if you prototype it as different pieces, you can bring in your own meshes later and make it a lot more custom without any more programming or redoing anything. And then let's go ahead and add the pegs. So let's add a cylinder. Actually, I added a plane. Didn't mean to do that. Now, the reason I didn't do a plane is because the ball will be bouncing in our machine here, and I didn't want it to, I want it to actually be able to bounce against the back wall with it doing physics, and that means I didn't want it to be something super thin, because I actually have trouble with physics. It's possible, it's just not something I want to deal with. All right, so now we got this in here. Let's find the angle and things we want. This, I'm going to kind of blow through a simple version of this real quick, because this will be the easiest part of what we do tonight. All right, it is, I want it touching. All right, we're going to rename the cylinder peg. It's a good name for a cylinder. We're going to make it taller. X is usually taller depending on how something's oriented. Try 5. Let's see. All right, and let's just make several pegs to get started. So I'm gonna hit Alt. Actually, no, it doesn't work inside of it. Forgot I was in a blueprint. We're just gonna right-click the peg and we're gonna duplicate, and now we've got peg 1. When that's selected, I'm gonna slide that where I want it, and we kind of got a nice little grid here, so I'm gonna follow the grid somewhat. Peg 2. And I'm going to make kind of a messy version to get started so we can get to the meat of this sooner than later. But I do need a few pegs so we'll have it something functional. Now, again, you could make this all a singular mesh if you wanted to and then get rid of the pegs. Really, we just need these for the physics. And one thing we can do, let's see what our physics looks like real quick to make sure we're doing it the right way. So I'm going to go to, all right, so this is facing the wrong way. We're going to have a pond in a minute, but right now we're just dealing with the default engine stuff. Okay, so now, and again too, we don't have any lighting or anything either. Just so if we had it lit, you can't see anything. So we're going with unlit right now, so we don't have to worry about lighting. But we can also look at player collision, and we can see what the actual collisions look like. And these are nice. These are good, nice, clean collisions. So when we make a little ball that falls through these pegs, we know that they're going to be bouncing off of it. So it's a good way to check really quick to make sure that this is how we want it to be. If you import your own mesh, you might have some issues with collisions. You might have to do some custom collisions. There's a lot of different ways to do that. We can't get into it right now, but if you had a question about that, I could. Oh yeah, it's like Plinko. pachinko, plinko. Yeah, it's gonna be like that. So let's go ahead and duplicate again. All right, and I'm gonna rush through this part here. We can make this neater and pretty later. Okay, a few more. Let's add a couple more on the bottom here. All right, so now let's add some pigeonholes to catch it. This isn't perfect, but again, we got the idea. So we've got a kind of a functional little pegboard now. And let's go. Let's add. Let's duplicate. No, let's just add a cube. Set a static mesh again and make it a. Gonna go with another standard cube mesh. All right. This one's pretty small. Let me see if another one's bigger. Yep, that one's bigger. Good. Okay. So these are just things that come cached, pre-canned in the engine. I'm going to skinny this up. Make it a little taller. Make it a little wider. See, it goes through the back wall again. So there we go. So now we can make our pigeonholes. And this will be important because this will be what actually we're going to score it with. So this will be what catches the ball here. And one more. All right. So now we're going to get the actual fun stuff. No. Put this here, maybe. Preemptively make this a little more fun. Okay. Yeah, you can move things as an object if you have it parented. Right now, I accidentally parented all of these to peg 16. So this is a good time to talk about parenting. If you have something pushed, you can drag and drop it underneath something else. That makes its primary location the location. But I don't want that to be the case. So I'm going to detach them. So I'm going to drag it back to peg 16 and detach them. I just did that because I wasn't paying attention. Compile, save, and compiling is mostly for the code, but it also solidifies the positions. And let's scoop that out. Okay, now we need one last thing before we can actually start making some action going on. We're going to need collision boxes. So we're going to need box collision. And this box collision is tiny. It is tiny. That's okay, because we can. I'm going to hit this lock, and I'm going to scale it up a whole bunch. Oh, it's because the box collision is part of the static mesh. That's why it was super tiny. It'll do that. It'll create like weird restrictions on sizes and stuff when you have it parented to something else. what I get for talking and working at the same time. So I'm going to get this one. Now that I'm going to unlock it, widen it up just a little bit. Skinny it up just a little bit. It can be a little wider. This is what we're going to register. This is what we're going to register a hit with. And so I'm going to just duplicate this. We're going to name these probably after the score we're getting with them in a little bit, so we can name them something like 5 points, 10 points, -2 points, whatever. But right now, we just need them here. Yeah, and again, this isn't perfect. This is just, but it is functional. That last one's a little too big. Scale it down a little bit so it doesn't overlap too many things. All right, there we go. Now we've got a pegboard. We've got a way to register the ball falling in, and we've got, there we go. So we're gonna make a new actor. This is it. This is our unlit world here, but let's go ahead and make a new actor before we start worrying about lighting. We're going to make a new blueprint class. So I just right-clicked right here. I'm hitting blueprint class, actor, and we're going to make a ball spawner. Ball spawner BP. And this is going to be, we're going to do another static mesh here, and this is going to be the slot or the top. It's really just so we can see where it is. Eventually, we're going to spawn it by pressing a keyboard command, but right now we just gotta make a prototype. That's something to keep in mind. You don't have to make the most complicated version immediately. Make the simplest version of it and iterate from there. Go from thing to thing to thing. So let's start with, we've got all these things here. This circle's kind of nice. Let's start with this circle. Actually, it's gonna be too flat to see straight on. We could do another cube, but that will be boring. All right, let's be boring. Let's do... Ooh, Arcade Edition sphere. I bet this has more collision faces. We're going to need that in a second. But let's go ahead and do... We're not doing background cube because that's like an inside-out normals. Make this little box here. Okay. And then we're going to add... We're going to add a arrow. Now what an arrow does is an arrow... Well, yeah, we'll parent it to the slot. The great thing about an arrow is an arrow always is exactly where you see it. And the more you work in Unreal, the more you'll appreciate that. So we're going to know which way down is with this thing. So as we need to call it and look at it or get its location or rotation or anything else, I don't think we'll have to do much with it in this game, but anytime you want to do something where direction might matter, putting an arrow on it helps a ton. So it's just, this is an information actor. You can use actors to essentially just track information for you in 3D space. So now this arrow will stay parented to this slot. So when this slot moves, this arrow will move. Okay. And then I'm going to, okay, so this is where it's going to get fancy. I'm going to make it to where we can have this move back and forth where we want it to in any kind of level. So a reusable ball spawner. So we're going to add, I'm going to add a billboard. And we're going to put that on the root here. Put it to the left. And then I'm going to duplicate that. And this billboard will be on the right. We're going to rename this one left border. We're going to rename this one right border. All things what they are. So when you're on the event graph, it'll make more sense. So this is going to move. So this is movable. So one thing, especially if you're on a different version of Unreal Engine, you need to watch. A lot of times it'll start static, I think in the older versions. If this was static, moving it would cause an error. So movable means like if this moves, the engine expects it to move. It wants to know. It's got to categorize everything when it does its physics pass and stuff, and it wants to know what is allowed to move and what's not allowed to move, because anything that's not allowed to move, it throws in a different bucket, so it doesn't have to iterate through it on the physics pass. Also things without collision, things like that. So you want to name it what it is. Stationary has to do with lighting, but we just need a movable mesh here. And let's go to the event graph. So on the event graph, here's where we do some programming, scripting, whatever you want to call it. We don't need any of these right now. We will use event begin play. So all this means is this is essentially your starting script. If when the level starts, when this is spawned in, not when the level starts, when this exists, the beginning of its existence, this will execute. So if you want something to execute on it, this is called an override. Essentially, there's all these actors that are just base classes, and all you're doing is essentially building on top of all these classes that already exist in the Unreal Engine. So this is a base class, is a base function, and this function will execute something as soon as it runs. You can override that function and create your own version of it, and that's what you do in the event graph. You're overriding the earlier event begin play function of an actor, of a base actor, and you're turning that into something that you need for your actor. So when people call it an override, that's what they're talking about, is you're just essentially giving it, this is your own version of it. You'd have to run the parent one to run the previous one, but that's a conversation for another day. So we're going to drag in the left border, we're going to drag in the right border, and we're going to drag in the slot. And we're going to drag off the slot. So these are the items, right? These are references to the items, and we can do things with these references. We can call preset commands. These aren't just like, this isn't its own programming language. This is actually C++ commands. They compile as C++. Now, there is an overhead to blueprints, but the blueprints themselves, you can actually look at them in the engine if you have a source version. And if you can make your own blueprints too. They are essentially modular pieces of C++. So there is some overhead, but they're not as expensive as people think they are. The majority of gameplay you can do in blueprints without much of a problem. There are times you definitely do want C++. There is a difference, but it's not as bad as people think it is. So you don't have to feel bad for using, unless you're doing some serious math on tick or something. Well, I don't know. It's hard to give generalities. There's sometimes you do want to go and write your own C++. When you're moving this cube around, you don't want to. It's just easier to do it this way. We're going to do move component 2, and we're just going to move the component back and forth. And we're going to get the relative location, and we're going to start left to right and then right to left. So we got the left border here, right? We know where this is in world space. So all we have to do is grab off and get relative location. The engine already knows the relative location of this. We don't have to do any fancy math. It just knows. So we drag that in. We got the relative location. and we can pick how long it does it. I'm going to go ahead and right click and promote this to a variable. And I'm going to expose this variable. That means I hit this little eyeball here. Now that I've exposed this variable, if I drag this into my level, you can see it's really tiny, so we're gonna have to make it bigger. It's really tiny. But if I drag this into my level, I can actually go over here to the right. Oops. Select the ball spawner, and you can see this over time variable is right here. If I change it over here, it will change what it default spawns as. This is the default value it will spawn as. But if I change it over, whoopsie. If I change it over in the level, I'm not used to having those in my way. Okay, there we go. If I change it over in the level, if I change it right here, it'll change what's called the instance value. So this is already in the levels, already instantiated, it already exists. So I am changing it just for the thing that already exists in the level if I change it right here where I have it exposed. So if I make this 5, like over 5 seconds, that's what that would be. I'm changing it just for this level, for this version of it in this level right here. But if I go over here and select this variable, I can change the default to 5 separately. So we can adjust it right there on the level, but have a default of 5. So it's going to move to the left border. And then when it's done, we're going to get the relative location. And the reason it's relative, world location is where it is in relation to everything else in the world, like it's on the pure grid. But relative location is just where it is in relation to this blueprint. It's different than world location. And so that matters because these components are only moving around in reference to each other. They're not moving around in reference to anything else. So the reason I wanted this a variable, because now I can copy this, paste it, or I could grab it over here and drag it in and say get. But I can get a reference to this, and I can make sure that the same number is driving the over time movement for both of these. So this will move to the left one, and then it will move to the right one, and then it's going to stop, okay? So let's give it a try and see what happens. See if I messed anything up. You can't see anything. Let's add a light. So we're going to add a light. We're going to just add a skylight for now. We're not doing any fancy lighting. So what a skylight is essentially this ambient light that wraps over everything. It's not as necessary if you're using Lumen, but for simplicity's sake right now, we're just going to drop in a skylight so we can see. And now I can go to lit. Let's just add it. Let's add a directional light. Let's get rid of the skylight because I think with Lumen, it doesn't work right out the box. I've been in Unreal Engine 4 so much lately. I'm a little rusty on my Lumen stuff. Okay, so we're just gonna add a directional light. Now we got some harsh shadows with a directional light. Some really, really harsh shadows, which is kind of cool. You can see where that little arrow is on the sun. We can change the direction the sun is facing. So there we go. Kind of more spot on here. But now we got some depth. There we go. And this is still super tiny. Let's go ahead and save the level. Let's save this map in our Peg machine. Let's make a new folder called maps. Let's call this basic Peg machine basic. No spaces. Basic. Okay. And save. All right, let's go to the ball spawner. Let's make it a little bigger here. Let's make it So when I hit this lock button, what I'm doing is making sure all these three numbers change in the same ratio together. Now it's 10 times bigger. Now let's see how it looks in the level. That's huge. So let's make this only 5 times bigger. Better. Okay. So that's not where I want it exactly. I'm going to go over here to my arrows, and I'm going to move it forward some. And I'm going to have it start in the middle. Okay, so you notice, though, that this left movement and this right movement thing, they aren't exactly where we want them. That's okay. I'm going to show you why I did it this way. And you're going to be like, wow, that's really smart. I think I'm going to do everything that way in the future. Because this is making things general purpose. Very important skill to make things general purpose. So right now we're going to hit play, see if it goes back and forth. It fell. All right, so we're going to figure out why that was the case. The slot component, well, one, I actually didn't have it going connected here. So I got to tell what to move back and forth, and this slot component is what's supposed to move back and forth. Also, this left and right border, I need to have them on the default route. So they're on the right spot here. So let's view where they are. All right. Okay, now, and we can see we're actually backwards. So I thought it was going to go left to right, but now it's going right to left. And it will do that and then stop. Okay. So we need it to do it continuously. That's all right. We can do that. There's more than one way to do this. There's more than one way to do everything. So just because we're doing it this way doesn't mean if you have a better way later, or different projects might require different things, or maybe your friend watches this and is like, no, that's dumb, do it this way. He's probably right. There's more than one way to do this. I'm just going to do it a simple way that will let us do it. So we need to move this over and over again. You don't really want to build in a hard loop. What we could do is once this is completed, we could go back to move on this again and then make it loop like that. I don't really like doing that. So what we're going to do is we're going to set timer by event. This is a common thing you're going to need to do in Unreal. This is a timer. If you want something to execute on a loop or after a certain amount of time, this is what you do. You drag off this event here, and this is you create the event. So you type in custom event. That lets you create a new event. You can name it. I'm going to call this movement loop. And so now this will fire immediately because it's 0 time, and it's not going to loop. It's just going to do it once. So this would go, and then it will go to this one immediately. What we're going to do, we're going to hook this up to move and unhook this one. We're going to do this looping, and we're going to do this immediately, not immediately. We're going to do this every 10 seconds. Or what we could do is over time, instead of making this to where we would have to come hard set these values over time, I'm just going to multiply this by 2, because essentially over time is being used twice, right? So we need 5 seconds for it to move to one, and then 5 seconds for it to move to the other. So we just need it twice. So if I change this one variable, now everything drives off the same variable. So now it's looping. The one thing though, this will not execute immediately. It will execute in 10 seconds. So if I need it to execute looping, so what it will do is it will go boom, it will count to 10, then execute, then count to 10, then execute, then count to 10, then execute. So I want to execute it immediately. By the way, this is a reference to the timer, so you can use it as a variable. We're not going to need it right now, but that's an important thing to know, because a lot of times later on you will need to do that. But we're going to go ahead and we're going to run the movement loop action. See, we can reference our own events. We're going to go ahead and run this. If I double click, it'll go right to it. See, run it immediately. So I'm going to run it, and then 10 seconds later, I'm going to run it again. Then 10 seconds later, I'm going to run it again. Then 10 seconds later, I'm going to run it again. And Let's see how that works for us. See, it's going to go at a different speed now because it's still keeping the same amount of time. I'm going to fix that in just a second. But there we go. And if we look at the ball spawner here, you can't see anything going on. That's because you didn't select it. Up here in this debug selector, you can select the ball spawner. This will only work if this is active and instanced in the level. Instance meaning like it's inside the level you're currently playing. If you go to the VP, you can select a version of it that's instanced in the level. We only have one, so it's pretty easy. And now we can see everything going on here. It's counting that down. It's moving. It's moving. There we go. It's all timed pretty nicely. There are some other ways to do this a little cleaner, but for our purposes today, this is a great start. So I can go to the viewport here. So we start on the left border. So I'm going to select the left border. That's this one. I'm going to move it to the left, to the right border. So it will start moving all the way across. But that actually doesn't matter as much here because you can see it moved in the world and we've got everything backwards because I'm real smart. You could just flip to the other side here and flip everything around and you'd have it the way it is in the blueprint, but it doesn't matter. So I'm going to select this this actor right here in the level, and when you got it selected, you can actually see in the details panel. This has all the different components of it, and you can actually move them around in the instance. So I can actually move this where I want it in the actual world. So that means I can use this in any level. If I change the pegboard, I can make it bigger, I can make it smaller, whatever. I don't have to go change a bunch of hard set values. I can just drag this in as a level designer. It's a level design tool. I can move those components. The code doesn't have to change. The code's the exact same, but it will still travel from one to the other. Now I'll show you the neat trick too. We put everything on that one variable. It all drives on that one variable. So if I go to that one variable that I exposed, where we can see it right here, I can play around with it. And this is level design tools, things you want to make for yourself or for other people so they can come in and toy with the level without necessarily having to program the level. So I'm going to make this over 3 seconds and then hit play. It should go a lot faster. I kind of like that. Maybe let's try it a little slower. See if we like that too. Kind of like that too. Let's start with that. All right, so we now have a pivoting spawner, right? And we can move these all up together, make it a little higher up if we want. And there we go. Now we have something that pivots back and forth that we can drop the ball out of. So we need one more actor to spawn. We need a ball. And this is going to be our physics actor. So we're going to new class. It's just an actor. I called it a physics actor, but it's just going to be another actor. And we're going to make sure that physics acts on it. Because right now everything isn't acting in it has physics, it has collision, but it's not running physics. It's not deciding where to go. It's being hard moved, hard calculated. We're going to select actor. We're going to call this ball BP. And we're going to add another static mesh. Name it ball. And we're going to get the Arcade Edition sphere. All right, I'm going to drag this in the level for sizing purposes to see. Oh, it's an interesting size. I think it needs to be bigger though. I'm gonna hit Control Z to remove it. Let's make this 5 times bigger. And again, I have it locked, so when I change 5 right there, it changes 5 for all the dimensions. Oh, and you couldn't see it because I was inside of it. So now it's really big. Compile, save. Okay, it's way too big. Let's go back. And maybe 3. 2. 2 maybe. Didn't mean to minimize it there. Okay, let's start with that size and then see what we like. Okay, so this is going to something we're going to spawn in the level to bounce off of these pegs. But we're going to experiment with it first without spawning it. We're just going to let it fall. So if I hit play right now, it's not going to fall. It's going to stay right there. Because it's just a statue, essentially. That's how I describe static meshes. They're just statues. So what we're going to do is we're going to turn the statue into a physics object. So we're going to go to this panel here. Unreal has all these variables and things they've made for all this stuff that just exists immediately. It's just you working within confines of a game engine that's already got a lot of stuff built. We don't have time to get into collisions and things like that yet, but essentially collisions will work out of the box with these things with just the basic collision set. So anything that hits this will bounce, but it's not simulating physics yet. So here in the physics dropdown, we can hit simulate physics, and now it will actually simulate physics, but it's still not going to fall. Well, okay, it did fall. Gravity must be turned on. But if gravity wasn't turned on, it wouldn't have fallen. It would have been bounced if something touched it, but it wouldn't necessarily have fallen. But we have gravity on. So right here in physics, yeah, enable gravity is already checked. So if we unchecked it, it would move when it gets touched by that and float forever. But because it was checked, no, simulate physics. I want that on. I want gravity on. We can do things, linear dampening, angular dampening, those kinds of things will change how physics affect it, whether or not it's got some inertia or not, if it's got a weight. But what we're going to do is actually look at constraints here, because when this falls, it could fall forward. It probably won't, but it could. Yep, see, it just fell forward and missed. So we want this to be as if it's behind a pane of glass. We're actually going to constrain it. So you can see these arrows. There's the blue, the red, and the green. The green's Y, the red's X, and the blue is Z. We want to constrain it to the Z axis. So we're going to go over here to the ball, and we're going to lock its position on not the Z axis, the X axis is what I meant to say. So now it can't move forward and backwards, only side to side and up and down. Aha. But for whatever reason, it was flipped on us. Which one was which? There we go. So see now, it won't fall forward. We can change where those pegs are to make it more exciting and change some weight and things. So let's go ahead and add some weight to this. Um, Mass scale, center mass offset. Everything's in a slightly different spot in all the different versions of Unreal Engine. And I just got out of 4. I've been working in 4 for the past few months because you got to bounce around. Sometimes you're in older projects or projects that were started a while ago. Let's just go ahead and up this to 50. All right, it's a little heavier now. So it got stuck. That's funny. One thing we can do is we can look at the player collision again and make sure. Aha, see? Here we go. That's why it got stuck, and that's why it's bouncing kind of funny. The collision of that sphere is misleading. It's actually not a sphere. What we're going to do is we're going to change that. I'm going to go into the static mesh here. And this is an engine content thing. So I'm going to duplicate it. And I'm going to move it to our project here. Because right now, see, this is an engine thing. So it's in the engine, but we need it to be a layer up. We need it to be in our project to mess with it. So I duplicated it so I don't have to mess with the engine version. But I'm going to move it to the blueprints folder. So now I have a static mesh that is similar, but now I can make edits to it when I'm going to edit its collision. So, excuse me. We're going to change this to the Sphere 1 version, which is our version. So now when I make a change to it, it's actually going to reflect it. And I'm going to double click on the static mesh. This is how you edit collisions here. So if I hit collision, wait, so I can go vision here, the lit button, and I can select player collision again, and then we see that blocky block. That's no good. That's bad. So what we're going to do is we're going to go to our collisions menu and we're going to remove collisions. Now we could auto convex collisions or whatever, but we're actually just going to add a simple sphere collision. And now if I go back to lit, we can see that that sphere collision, thankfully, serendipitously, lines up exactly. If it didn't, I could come over here and I could take the primitive here in this array and I could change its size, location, whatever. I'm going to hit Control Z because I don't need to actually edit anything about it. But I can go back to player collision. You can see it's a perfect sphere, and then back to lit. It all lines up. That was serendipitous. But I thought I was going to have to move this and resize it. You can change the radius and everything with these primitives. This is nice, simple collision. It's going to be cheap, but it's going to match up with our static mesh exactly. So now we've actually got something round. So when I hit play, now it behaves as a round object, and it shouldn't get stuck randomly. Much better, much better. Much better. There we go. So we got physics. It's locked on X, so it won't fall forward. Now we just need to spawn it at the right time. So what I'm going to do, I'm going to delete it out of the level. I'm going to go back to our BP ball spawner, and this is actually going to spawn a ball. Now, at first, what I'm going to do is just do it on a timer, another timer, until, because we're going to have to make a pawn to do it. We'll make a player controller to do it off of the keyboard. And we will do that in just a moment. But I just want to make sure it works like I want it to. One thing at a time. That's my rule. And so let's just prototype it. So we start the movement loop. We start the timer. Then we're going to just create timer. Oh, sorry, set timer by event. You can do timers by functions and stuff too. We're not covering functions yet. Probably at some point, maybe today. But I love a good function. But right now we're just doing events. An event and a function is very similar. The function is reusable. If you know anything about computer science, functions deal with memory differently and things like that too. So there's some benefits to having things a function. But right now we're just going to add another custom event. We're going to have this ball spawn test. And we're going to make it go every 2 seconds on a loop. And this is just essentially in lieu of a player controller. We're just going to do this action every 2 seconds. So don't worry about that for now. That's just our cheat. We can even comment it. We can call this cheat or testing timer. So if anyone comes in after us, they'll know that this isn't important if it's unhooked, just for testing. But we're going to make a function that actually is important. We're going to make a custom event, and we're going to call this spawn ball at location. Actually, we're just going to call this spawn ball, because why not? And we're going to get a reference to the arrow. Remember the arrow we put in here? We know where it is. We always know where it is. So we don't have to do any fancy math or anything. We just get the arrow. So we can drag off this, go spawn actor as pre-made node here. And we can get world location of the arrow. Actually, not location. Get world transform. Now, what a transform is the scale, the rotation, and the location all in one, essentially structure. Oh, yeah, it's mad. If you ever compile it without this hooked up, it will get mad. You just hook this up, and it will not be mad anymore. Actually, it's still mad. Oh, it's mad because it don't have a class. Remember, we just made the ball VP. So we're going to spawn the ball VP right here at the world transform of the arrow. And this is probably going to go wrong for several reasons, but let's just watch it go wrong. Oh, wait. Oh, yeah. So first off, it went wrong because I didn't actually hook up any logic to it. So this will spawn a ball whenever I call this, but nothing called it. So we're going to call spawn ball. Now we can call it every 2 seconds to test it out. Oh! All right. So we are spawning it with the scale. Not the ball here. We're spawning it with the scale of the arrow. And the arrow's just got some random 5 times scale on it. We don't want to do that. So I'm going to right click this spawn transform here, and I'm going to hit, actually I'm going to hit Alt and unclick that for a second. Then I'm going to right click it and then hit split struct pin. And you can do that again too if you want to get right to the floats. But this is essentially an array or a struct. I'm not exactly sure the base class, but it's essentially 3 floats, right, in X, Y, and Z. But we only need the location, really. The rotation doesn't matter, and the we want it to be the same scale as we already decided it should be in the ball BP. So we're going to spawn it at its natural scale. So instead of getting the so now it will autofill these in, but we do need it to spawn at the location. So I'm going to grab this out, get world location. We need the world location, not the relative location for this, because it matters where it is in the actual world when it's going to spawn it. And now let's see if anything goes wrong. Okay, it's pooping it out a little too high. That's close. It's getting close. Okay, so my cat is wanting inside. Give me just a moment. Oh. So, okay, where were we? Yeah, we just got the ball location. So that's a little too high. Instead of doing some math on it, we're just going to drop the arrow a little lower. And now let's see if that's how we want it. Still too high. That's all right. Drop it a little lower. See, I don't like the fact it's actually having to... you can change collision channels where it actually won't kind of collide with the spawner and stuff. That's just going to take... If I do everything just right perfect, it's going to take more than one night. But I do like to mention it in case someone kind of give you a little rabbit trail to run off of if you are having that issue with the way you would like to do it. But see, notice I'm just dropping the arrow lower, and so changing the constant position. So the game is naturally tracking all the variables we need. That's funny, it got stuck. All right. We've got some of the basic logic going. We need a lot more to make it a game, but let's go ahead and take a break from this and move on to a few basic colors. So one easy way we can set a color. Let's go back to our materials folder. Let's just make a basic material that's color, a basic color. All right, there's no reason to make it complicated. So we're going to right click, we're going to hit material, and we're going to call this, sorry, my cat's pushing on my keyboard. She's right here, if you can see her through my kind of masked video. We're going to call this basic color for map. And you just do that so you can tell what it is at a glance. Or if you're searching for it, you can type _mat. You can just see mats, you know, stuff like that. So this is a mat. We're going to actually get rid of the specular, get rid of the roughness, because that actually cost PBR material. That actually cost some computation if it has to add any of that. So right now we're not going to add anything. Or we could, well, you know what? I'll show you what we'll do. So first, let's hit the 3 button and click right here. We just made a constant. What's a constant? It's a 3 vector. It's a 3, not 3 vector. It's a with a 3 plane vector. It's you hit the 3, you click, you get a constant. This is a color, right? A color can be 3 vectors. This could be a location or whatever, but that's what it is. This top one is the color. We can move that to base color, and then we can select this little dot right here, and look. Now we can make a color. And we got a ball. What if I wanted to see what this looked like on a different mesh? I could actually have the mesh selected here. In my blueprints, I have this actual static mesh here. The rest of my blueprints, these aren't static meshes, these are primitives. Or like things cached in the engine. They are static meshes, but they're not ones I can control. But I'm going to select this one right here. And I'm going to go to basic matte, and I'm going to select this little brick. And you can't really tell, but now we're actually viewing it on our static mesh. If I had something a little more different than the basic one, you could tell. So we could just go in and make a basic color for everything, but we're going to do it a little easier than that. We're going to right click this and create a parameter. And if it's a parameter, that means we can change it later on. That's all that means. If it's not if it's a constant, it stays that way. If it's a parameter, it's really a variable or whatever. It can be changed, but it's referenced by its string name. So name it something simple. We're just going to call this color because it makes sense and it's easy to spell and type if you're American. So now it's got a default value. And we can go over here to our materials again, and you can see our map, and you can drag it and drop it on something if you wanted. Or let's see, you could go to ball, and you could go to the material, and you could select you type basic color, and you can get our basic color mat. And now we've got a blue ball that will spawn. But let's make it even easier than that. Let's right click it again and create a material instance. Now this is a version of the material, so it will reference this, like the materials, the basics. The instance is a different instance of it that we can make a separate change to a parameter without changing all of them. We can change something specific about it by that whatever referencing this instance. Okay, so we're just going to name it basic instance blue. All right. And when I double click this, you can see here this global parameter value. I can check it, and now I can actually change it, and I can make it a different color. I named it blue. You can save a sibling of it. You can save a child of it. A sibling is just like a duplicate, really, with a different name. But I named it blue. Gonna rename this. We could do a dynamic material instance and get really fancy. But right now, do I want to do that? Is that worth it? Nah. Okay. So we'll just duplicate basic 1, duplicate basic 2. All right. So we got blue, we got pink. I could just make these different colors here. We got green. Okay, so let's change this one. What color should this one be? Any votes? Got blue, green, I guess yellow. All right, so now I got these different colors. We can easily apply them on some different things to give this game some pizzazz. So let's go to the peg machine here. Let's change this material to, I type in basic color, and now I got my instances here. These reference, they share a RAM reference, so they're actually lighter to use them as an instance than to use them as different versions of it, because they're all referencing that one thing, so they can share some memory. That's why you would do it that way. That can get way more complicated. Like this is you would notice no difference in doing it the wrong way or whatever, but this is a good way to get started with the process of understanding how to share GPU memory of materials by creating instances. So the white pegs actually look kind of nice. So I'm just going to leave those there. And then we're going to go to the ball spawner here. We're going to make this basic color. Make it green. Oh, wait. No, it's green. That's already green. No, why did you let me do that, guys? I guess pink. I'll make it easy to see. All right. Now we've got some color in our world. We're gonna change those. We're gonna change the ball size and the peg locations just a second. All right. Let's make this a little higher up though. And all right, so we have so far made a object that moves back and forth that we can change the distance it moves back and forth by changing some of its components right here in the level. We can change exactly where the ball spawns actually here in the level too, not just in the blueprint, but we have the ball spawning there. We can move it up just a little bit. So now the ball spawns level with the level. Boom. Oh. Aha. So there's one of our problems. The ball is actually spawning into the wall. Now we can see it. And see, because I have the locked where it can't fall forward, it can only go side to side. So that's a lot of fun. Let's move it. Let's make the ball just a little smaller, actually. And we can go back to our ball BP, and we can make this 1.5. And that might solve it right there. It does. If that didn't, I was going to move it forward a little bit. But there we go. That solves that problem. All right. So we got colors, we got blueprints. Let's make it score. All right. We're getting there. Okay, so we're going to go to not the ball spawner, the peg machine. Let me move this output log here. We're going to go to the peg machine, give it a quick save, and we're going to go to the event graph. Actually, no, here. And we're going to name these, not static meshes here. We're going to name the collision boxes. And maybe let's rename them to the score we want. That way we can recognize it pretty easily in the event graph. So I'm going to call this one score 5. Rename score 10. Rename score 2. Rename score -2. Rename score 100. Being silly. Okay. But now I've got, I can go to the event graph, and these are actors I can reference. When I click on them, I can go scroll down all the way, and it has overrides I can create. These are things that are, again, exist on every component of this type that can have an overlap. And you can override what happens when they get overlapped. So I'm going to go override on component begin overlap. When this gets overlapped by another actor, we can do something with that information. So I'm going to cast this. Now what a cast is, it's a rabbit hole here. But I need to look at this actor and do something with it. Casting can get expensive, but it's not something you never do. There's just different reasons. Sometimes you want to get an actor. Sometimes you just want to compare a reference to an actor. But the best way to deal with not casting too much is to make sure that you're referencing things that you already know are in the level. Like you're casting to a manager that's already loaded in the RAM. If it's already loaded in the RAM, you don't want to load things in the RAM that aren't there. You don't want to have to just cast to objects that object after object after object you don't really need, except for that one function you put in there or whatever. You just want to be smart about how much you're putting in RAM. Every time you load something in an application, it's in RAM. And so this is, and it also creating a reference to it, it is having to like look at it again and stuff. It's a little more complicated than that, but this will be totally fine, especially for this application. We got plenty of headroom. We're going to do cast, and we're going to cast to the ball BP. What this is going to do is it's going to say it checks what class is touching it. So when something overlaps it, and we need to make sure that this is on begin overlap score 5. When something overlaps it, we need to make sure that this is actually triggered when it gets overlapped. So usually they start yes, but I want to take a look here. So with all these different components on here, we go to, we're not simulating physics on it, collision, overlap all dynamic. That means anything can touch it. It's not going to block anything. And then we're not generating hit events. That means when something touches it, it creates like a hit, like a ray trace hit. But we are generating overlap events. So when something enters the same space that this is in. So as we cast this, if this cast succeeds, then we know that the actor that overlapped it is the ball. So then we can do something with that information. We could reference the ball and do something with the ball, but instead we're not going to. We're going to well, you know what? This would be a good time to delete the ball. No, I'm going to delete the ball on a different thing. Okay, I'm sorry, I'm thinking out loud. We're going to delete the ball on a kill plane that we're going to make in just a minute. But first, we have our different scores here. We need to make a variable. We're going to have to do some math. You could have a score manager. I would not do this on a widget. A lot of people, they want to do it right on the widget. It's not a good idea. Widgets are better to read things with. They're not really reusable. You don't want them loaded in all the time unless it's like the HUD. Like the widget is better if it just reads what's going on and displays it and relays commands and relays information. You really don't want a widget to own a lot of code. That's not specific to the widget itself. If you're new, that will make sense later. You'll think about it and be like, oh, he was right. He was so right. So we're going to go here in the corner of this, and we're going to add a variable. We're going to hit this little plus right here, and we're going to add a integer. And we're going to call it score. So for our purposes, this thing is very specific to how the score works. We could put the score on the pawn, on its own score manager actor. This, for our game right here, it makes perfect sense just to keep the score right here. But it doesn't have to be kept right here. We're just going to do it like this, keep it simple, and there's no reason not to. So I'm going to get the score, and I'm going to add it. Now we could add it by another variable. Right now we're going to use magic numbers or constants. We're just going to make a constant. This is 5. We're just going to add 5 here. So I take the score, I add 5 to it, and what happens? Nothing right now. It just finds the number and doesn't do anything with it. So we're going to grab the score again, hit set score, and we're going to take the score, what it currently is, add 5 to it, and then set the score as that. So then it will be 5. So the next time it would be 5 plus 5. The next time it would be 5. It would be 10 plus 5 or whatever. So now the score actually changes. We can print screen the score just to see it grow. Nope. We don't have a pawn set static position. When something falls down this far one, we should see a print screen. What that is just a log, but you can see the log on the screen as you're playing. All of those aren't set up yet. It's not hit the one. We need it to hit the one in the corner. Is it going to do it? It did it. Yes, 5. And it will continue to add to it, but apparently it's harder to score that corner pocket than I thought. So we're going to display the score with a widget in just a minute. But right now, let's just finish this. So we're going to on component begin overlap for this one. Go to this one, hit on component begin overlap for this one. Go to this one, hit on component begin overlap for this one. Go to this one, hit on component begin overlap for this one. And so I messed up. See, I hit on end overlap. You can tell because it's itty bitty. It's less information on that one. So I'm going to go on component begin overlap. There we go. So now I'm going to keep them in order just for my brain so I can know that these are in order. Instead of having to add the score up every single time like this, I can actually make this a function, and I can right click it and hit collapse the function. And what's this function called? This function is going to be called set score. So if we had multipliers and stuff like that, we could essentially do the multipliers inside of this function and not have to redo it for everything later. I don't like redoing stuff. So I'm going to drag this magic number into here. And boom, now I've got a pass parameter. So the same way in like traditional coding, when you have like this function takes these parameters or whatever, right? Additional score. You can do the same thing in Unreal. So you're passing a parameter through it. When you drag it to the little box, that's what you're doing. So now I can make the additional score for this one 5. So there we go. Boom. I'm just going to copy paste, copy paste, copy paste, copy paste. All right. So that's one of the things about blueprints is we are going to have to kind of drag on each of these that we connected up, that the other actor, and it checks what actor it's casting to on each one. We could do a function that checks and then passes it, or we could do a macro, but there's no reason to do that right now. Not for this. All right, so we have this one. We're going to add 5 to it. No, actually, that's begins 10. 5's the top one. So this one, we're going to add 10 to it. I named this one score 2, so we're going to add 2 to this one. I named this one score -2, so we're going to add -2. What happens when you add a negative number? You're actually subtracting a number, but we don't have to call something subtract node. It knows that. If you add a negative number, you're essentially subtracting a number, so this will work. And then here, we're going to add 100. And we're not going to be able to tell the score at all still, because we don't have a HUD. Okay. So next I guess we want to see the score next time. So it's time to start formalizing some things. We're going to need a pawn. And we're going to need a player controller. We don't need anything fancy. We're just going to do the basics. So we're going to go over here to content. Do okay, sorry. I was thinking about too many things at once here. Okay, so we're going to add a player controller. So we're going to go inside of our peg machine here, go to blueprints, and we're going to create a player controller. So when I hit right click and I hit blueprint class, I'm going to just hit player controller, and I always call my player controller PC for player controller. This is my player controller class. Now I want to show you something. In the output log, project settings, plugins, output log. Nope, nope, nope. Okay, I'm gonna need another T in just a second. Starting to lose my focus. We need to go to the project settings, and we're going to look at maps and modes. You can see it says game mode base. You have the default pawn, default HUD class, default player controller, default game state base, default player state, and default spectator pawn. And you also have a default game instance class. Now, the game instance is where you store anything that goes throughout the entire instance of the game. So you can load up level after level after level. Right now, everything we're doing only exists inside the level. You close the level, it all dies. The game instance doesn't die, it stays. But we don't need a game instance right now. But we do need a new default pawn. And we need a new default. These are just the vanilla engine versions, right? And so usually if you come into a prefab version, you're going into like third person blueprint or whatever, you're getting all this stuff already done for you. But this one we're starting clean, and so we can actually select a new player controller class. Oh, but we're gonna have to make a new game mode to do that. What a game mode is essentially a package for all of these. It will load in all your defaults for this. So we're gonna make our own game mode as well. But we don't need to make all of these. We just need to make a couple of them. Why is it this way? Multiplayer. That's why it's this way. A game mode has everything to do with multiplayer. Your player controller has everything to do with being separate from a different player's controller. The game state base is what things can reference. Everybody can reference like the score or something across multiplayer. Player state is it's displayed information across multiplayer. Most people don't know how multiplayer works. I can tell because I watch a bunch of tutorials where they poorly explain it. We cannot talk about it here. It is a huge thing. But Unreal Engine is inherently a multiplayer engine, and things are made with multiplayer in mind, which includes this. So you just got to know that. This is this way because of multiplayer. It doesn't matter for us right now. It just is this way. So we're going to go back here, and we're going to make a new blueprint class. Game mode base. We're just going to call this Peggball. Then GM. There we go. Now he's got a nice pretty name. And then we're going to make a pawn class. We're going to call this Peggball pawn. There we go. This will be the basics. When everything loads in, it wants to know a player controller it's going to do. It wants to know a pawn it's going to load. It wants to know some defaults. And right now it's just going with the engine defaults. So we need it to just default to what we actually want. So now when we go to settings here, we can actually select the Peggball GM, which is our custom one. And we can change what its default stuff is too. We can do that inside the class, but we can also do it right here. So we don't need a default pawn. We need the Peggball pawn. And we don't need a default game controller. Player controller. We need our player controller, which I called PC. Now we're actually using our stuff, and it doesn't move. Why? Because we don't have any code on it. We don't doing anything with it. So I'm going to open my player controller and kind of build this from the ground up here. This player controller, you can do things like show mouse cursor by default. This is where all your like controller stuff happens. But one thing we can do is we can make it to where the pawn Well, it'll auto possess. This player controller will auto possess the pawn that we have with the game mode. So this player controller will automatically know that its pawn is related. Now we can change what pawn it's possessing inside of the player controller too, but we're not needing to do anything that fancy today. The engine itself has logic that handles this. So this player controller will launch this pawn because we told it that's how it works by default in our default settings we just made. So now with the pegball pawn, we don't got nothing in it. So let's add a camera. All right. There it is. There's our camera. And it just kind of sits there. So we can change where it's going to spawn in. Because right now it just kind of does it where we hit the button, right? We can change where it's going to spawn in by adding a player start. Now the player start, that's where it's going to put the pawn. Why? Because that's what your game mode is telling it to do. The game mode is in charge of multiplayer, and it's got to figure out where to put all these people and pawns and stuff when it starts. We don't have multiplayer. That's good. It only has to worry about one pawn. I think it's facing the wrong way. Yeah. But there's logic already built into Unreal to find this player start and put the pawn there. See, and that's why it works. Okay, I want you to know that because you can change that logic. It doesn't have to stay that way. That's why it does that. I don't have time to open up every little thing I'm talking about and show you, but if you go into the game mode, you can actually change where the pawn launches and what it looks for when it launches. Right now, it just looks for the first one of these it finds, and it launches it. You can change rules about how it launches different multiplayer things. Let's see where this is at. All right. A little not far enough. But I will have this floating in space here, and we will have our perfect... Ooh. Ooh. Move that real loosey-goosey. Keep it a little further back. Let's see. A little down. A little down. A little closer. All right. That will work for now. What we can do too is we can change. We actually go into the pawn. We can actually change the camera values because all this stuff, again, it's all default Unreal Engine stuff. These are variables that Unreal has made and exposed in C++ for you to edit on the editor in real time. Beautiful. We could change post-processing effects, things like that. You can change it on the level. You can change it with it's got so much you can do. We can't talk about it all today. I keep trying to pick where to draw the line. So if you have any questions, though, just ask, and I will see if I can answer it. I don't know everything. I do know how to get by, though, so I might be able to help you. So the field of view, let's actually like lower it, make it a little more telephoto here. Let's see what happens. Whoa, there we go. And zoomed in, right? That was way too much. So if we go back to our pawn, again, I'm just in a pawn. I just gave it a camera. It just uses the camera by default as a pawn. It uses its first camera. This is because Unreal has made things to work this way. You can make it work however you want it. Right now, it's just working the defaults. All right, I kind of like that zoom a little bit, but okay, we won't finagle all day. Let's leave it a little zoomed in. All right. Let's go ahead and make this a bit fancier. No, we're going to add the controller, then we're going to add the score. Because we already got the score built. Let's go ahead and we're in the middle of the controller stuff. Let's do it. All right. So in the PC, this is the actual controller. A lot of people like to put the controls inside the pawn. I don't like doing that. The reason why is because if you swap the pawn, let's say you want to control a car now, you might not want to swap all your controls with it. Maybe you do. If you're making a Mario game where you want to throw your hat on something and suddenly have different controls and you swap pawns, that might be a good time to put the controls inside the pawns. But a lot of times you don't. You just want to, even if you swap pawns, your controls still want to be consistent. And you can still change things how you need it or whatever. But I like consistent controls, so I like to put it in the player controller. This is, and again too, this can see your inputs naturally. A player controller and the pawn, they can see your inputs naturally. Other actors can't. So we're making a PC game, so we don't have to worry about abstracting. There is ways to do it. We're not doing it tonight, to abstract it to where a control pad and a keyboard and everything can all abstract and do the same command. But we're not doing it that way tonight. We're just going to, let's see, space. Let's just type space bar. There we go, space bar event. Now, when I hit the space bar and I hold it down, this will fire. When I let it go, this will fire. It's that simple. I can do something called an event dispatcher. What's an event dispatcher, you may ask? It will listen to anything that is subscribed to it and tell it when it's firing, and it could even pass parameters to it. We just need to do a basic one called space bar pressed. We don't even need released. We're just going to do pressed. And when I pull this out here, I can call it. When you call an event dispatcher, anything subscribed to it will execute. How does that work? I will show you. So now I can go over here to not the peg machine, the ball spawner. And I can, instead of doing this testing timer, let's get that out of the way. So first, I can get my player controller. How does it get a player controller? Well, this is a basic function that just goes, what is the player controller? Because there's always a player controller. There's always one. And so it will just get it for you. But it will get the general player controller for the engine. So we need to cast and get the PC. We need to cast a PC. Why am I casting? Because the player controller is something that's already in RAM. And it's very light. So looking at it again when it's already in RAM is not going to be a difficult reference to pull in. Casting isn't a sin. It's just something you got to understand what you're doing when you do it. So I'm going to cast to the player controller. And when I do, I can now have access to the player controller. I can do something with that. And what I can do is I can subscribe to that event dispatcher. So I'm going to say bind. That's the name. Bind. Yeah, I wish they call it subscribe in like the documentation, and then you have to type bind to get it. Why don't they call it binding? I don't know. We're going to bind to spacebar pressed. Now, this is called a delegate. This event will fire whenever the spacebar is pressed because we just subscribe to it. So I've got to drag off here to create an event. I got to create a custom event here. You can hook up another event to it. I could hook up this event to it or whatever, right? But we don't have one we want to hook up to it yet, so we got to make one. Custom event class. We're going to make this is going to be ball. Wait, we're just going to call it spacebar pressed because that's really what's happening. Now we could have just hooked it up to this, but I like to be separate because maybe I want something different to happen when the ball spawns from some other thing or whatever. Keeping things separate can be good or it can be bad. Just depends on what you want to do. So we're going to spawn ball. So now we hit the space bar. This will listen and also execute this event when we hit the space bar. And this will spawn. So now we have a game. Every time I hit the space bar, it spawns a ball. Oh, that's funny. All right. So the way we did that overlap for the balls to do the score, which is working, by the way, we just don't have anything connected up to it yet. Just display it. We're about to. We could do another layer that is a big layer that catches all the balls, and when it overlaps it, we destroy the balls to make sure, because we don't want, if you just spawn balls, those will fall infinitely, and they will calculate for infinity until the game just decides they're too far away to calculate, and garbage collects them. They will fall for a very long time, and we don't need them to fall that long. We just need them to fall for a moment. So what we can do is, instead of doing a big kill floor collection, we can just make sure these balls don't have to live very long. So we can actually go to the ball, and we can actually change its time to live. What's it called? Is it called time to live? Oh, it's called lifetime, right? No, we gotta go to default. We gotta go to the active defaults here. Life. Initial lifespan. If it's 0, it lives forever. Maybe 12 seconds. Okay. Now, without any code, without any kill floor or anything, this ball only lasts 10 seconds. Or 12 seconds. So when I hit spacebar, sorry, I didn't have the screen selected. When I hit spacebar, it will spawn. It lasts plenty long, and it will. I know it's going to delete itself later. Let me prove my point real quick by changing. If I go to the ball again, change the lifespan to 2, just so you can watch it disappear in 2 seconds. It's gone. See, it cleans itself up. So there we go. Problem solved. No extra code needed. Cut with the grain. There's no reason, if Unreal already has solved this issue, there's no reason for you to have to sit and program custom solutions. Cut with the grain. Do it the way Unreal expects you to do it. And there's a lot of times you will need custom solutions. But right now is not one of them. Boom, boom. Here we go. And now if they get stuck too, they don't stay stuck forever. The kill floor wouldn't have fixed that problem, right? But now if we spawn too many and they get stuck, uh-oh, but the game's not over. In just a moment, they're going to unspawn, and we'll have that back. Self-riding. Okay, so we're getting close, guys. We're getting really, really close. We made our own player controller. We made our own pawn. We made our own custom ball spawner that you can size to fit in the world. We did custom collisions. See, this is a lot of fun. We're going through all sorts of things. We did materials, all sorts of things that you wouldn't necessarily get when you're watching somebody do just one system or one item. You don't necessarily understand how it all works together. So that's my hope, is we can build something where you can kind of see how this is all working together to create some kind of unified system. So now these balls don't exist forever. Okay, it's time to display score. So we're going to make a widget. Pure and simple. Right click, and we're going to go here to, you could go through the blueprint class thing like we did for everything else, but here it's easier just to go to, if I can see it, user interface, and then select widget blueprint. And we're just going to select the user widget, and this is going to be called score display. You call it the HUD or whatever. There is a HUD class. I don't ever use the HUD class. It's a little different. It's really kind of, it's a specific widget. I've always been able to do everything I want to do with my own widgets. Just take with that information, do what you will with it. Some people call widgets. I'm just gonna do _W. That's what I usually do for widgets. Every team I've worked on, somebody's got a different way they like to do widgets, or name widgets. Just as long as you're consistent, that's the important thing. Right now, in a project this small, you're like, oh, I can find everything. But one day you're gonna have like 40 billion things you're looking through, and you're gonna be like, ugh, I wish I could just hit _W and see all my widgets, or know what something is just because of the way I named it. Okay, so now we got a widget. We're going to create a canvas. We could do a 3D widget, put it in the world, but I'm going to do a basic widget so I can show you kind of how we can also do like a close button stuff too. I'm going to add a canvas. Canvas just lets you see the screen, really. You can kind of size it to what the screen is going to be, to kind of see how everything's going to go together. Widgets are a whole big thing. We're going to add some text. And we're going to just drag it onto the screen here. And this text, this is the anchor corner. It will always fit to the anchor. What does that mean? Well, if its screen gets skinny, like a phone screen, it would anchor here and it would be off the screen. If it's really huge, like a 4K screen, it would be anchored there. It would be anchored here for 1920. See, I can move this canvas around and I can see where the anchor point is going to match. You can use different anchor points. You don't have to use this corner. You can change it. You can pin it to where it's always consistent. So when I change the canvas panel, it stays a lot more consistent. And that's what we're going to do for this. What is this? I'm just going to go over here. All these options, beautiful options. It's just your standard font editing for the most part. And we're just going to call this score. And boom, we got score. Now, I'm going to add another text box underneath it here. I'm going to anchor it the same way with the 4-corner pinned anchor. I'm going to put it next to it. And I'm going to call, just type in a 00 for like a standard number here so I can see what it'll look like. This will be my number. I can shorten the text box here. You can do all sorts of things with this. You can change the centering. Anything you can do in PowerPoint, you can do here. So as you're getting used to widgets, just keep that in mind. You've got a lot of your standard font editing, right? So we got 2 different fonts. And so this will do nothing right now, but you can see it. So I'm going to go ahead and add it to the screen so we can see it when we hit play. So on my pawn, do I want to do it on the pawn? It doesn't matter right now where we do this. Just so you know, widgets are connected to the player controller, so not everything can see widgets, but most everything can. But like the game mode can't see widgets, for example. So don't do everything in the game mode. You know what? And I might be slightly wrong about that. But again, I'm just trying to remind you, Unreal is made for multiplayer, which has rules for how things interact and share stuff over a network. And you have to, most single player games, you just need to, when you build it, just don't build it within the framework that works for a single player game, which is most everything. But okay, so we're just gonna go to the player controller on event begin play. It could be anywhere, but I'm gonna do it here, and I'm going to create a widget. And that's different than an actor. A widget's a different kind of class. It's not an actor, it's a widget. And I'm going to create one, and the widget I'm going to create is the one we just made called score. So you have to like spawn it the way you would spawn an actor, but it's called like creating a widget. Why it's not called spawning a widget? I don't know. I didn't make this thing. So here, once you created it, it exists in RAM. You're not going to see it. I'm going to hit play. You're still not going to see that widget. But it's in RAM now. It's taking up valuable memory. So we need to put it on the viewport. The viewport is something inside of Unreal Engine, which is essentially your monitor. If something's on the viewport, it's on your monitor. That's what's rendering the rendering face of everything. So we're going to add to viewport. And that, the Z order is the layering right now. As it says, the higher the number, the more on top the widget will be. We don't need to worry about that because we just got one widget. So now when I hit play, you can see right there, it's kind of off corner. So let's fix that real quick. Let's move it in. Let's move it in. And again, there's 100 ways. 100 ways we could do this. We could, but I'm trying to keep it simple. Okay, so there we go. Now we can see the score. Part of that's because my screen, I'm doing it in kind of a locked-in, sizable screen, right? Kind of an odd screen, but still, yeah, I can see it now in the corner. But if I spawn, let me select the thing. If I spawn the balls, do I get a score? No, I do not, because I didn't hook anything up to it. So let's hook up the logic. I like the widgets to read things. I like them to read things. So what I'm going to do is I'm going to make it just read it. I don't want it to do any math. I don't want it to do any work. I don't like it when widgets do work unless the widget's moving its own stuff around. I like widgets to read and to relay. So I'm going to go here. Widgets have an event begin graph. They have a graph. You can do pretty much everything you can do on an actor, you can do on a widget. You can grab your stuff. You can mark them as a variable here. Is variable or is variable. I need this one to be a variable. That means it can change, right? It's variable. But you can access that on the event graph. I could drag this text block in now and use it like an object, right? It's something I can reference. But I just want to read the score from the peg machine. Okay, so I could have a score manager. I could put this anywhere. I decided to put the score on the peg machine. That's all that is. I just decided to. So I'm going to go over here to the 00, and I'm going to go to the text, and there's a little chain here. That's create binding. When I create binding, the widget itself will decide constantly what to change this text to. So it will just read numbers and then tell me what to do. So instead of having to do a whole bunch of complicated logic, again, cut with the grain. Just do it the way Unreal Engine wants you to do it. We're just going to get an actor of class, right? So this reaches out into the level. It goes, I need an actor of a class. You could get an array of actors, get all the actors of a class. We're going to get this actor, and the actor we need is the peg man. Not the peg. Is it the peg machine? Yeah, I called it the peg machine. Okay. When I hit this arrow, there we go. Yep, the peg machine. So the magnifying glass will take you to it in your browser. It's the peg machine. I could create a variable here and reference that variable, or I could just get the actor every time. I'm going to do it the neater way for you guys. I'm going to hit Control X to cut. I'm going to go to the event graph. This is just the main place you can put your code. That's all the event graph is. And I'm going to Control V to paste it back. And on event construct, that's the event begin play for a widget. When it launches, it's going to reach out into the world. It's going to reach out to the world, and it's going to grab the first actor it finds, which we know because of the way we're designing the game, there's always going to be this one actor. And we're going to promote it to a variable, and we're going to name this variable peg machine. So now we have a reference to the peg machine, okay? And we can use it. So if I go to get text, I can drag this peg machine reference off. Now, this will work essentially on tick. Now, it's optimized for widgets. It's not, don't worry, it's not dirty. This is what it's for. It's for to live update things. So don't worry that it works constantly. Just don't, but keep in mind, just don't do a lot of math here and stuff, right? Just make it real simple. So this peg machine, I'm just going to get the score. And I'm going to drag it right here. And now it will change that integer, right? If you know anything about programming, it's a number. It's going to change the number to text, which is a type of string, but it's not a string. This is text. It's a different kind of value. But one thing I'm going to note, just from experience, there are moments, split-second moments, where maybe that variable hasn't been created yet, and then it tries to grab nothing, and you don't ever, 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 ever want your game to grab nothing. If you're worried at any point your game is going to grab nothing, which is a lot, you can just go is valid. That is a bool that you can create a branch on and check if it's valid, yes or no, and do something. Or there's even a nice pre-made thing for it. It's got the little question mark. This is called a macro. It will do that for you. Just if you double click on it, look, it's valid with a branch. It's a macro, right? This is something it's already done for you. That's all of what a macro is. It's just event graph stuff that's already done. You can reuse it. So if it's valid, we want it to do that. If it's not valid, we just want it to return 0, 0. There we go. Now it won't break if it misses it for a second. There we go. The score is 0. And now we should see the score. We didn't have to program really anything. The score, we already did the addition for the score. No, that was to -2. So one thing that might be nice, let's go ahead into the ball spawner here. And not the ball spawner, the peg machine. Go to the viewport. Let's add some text, some 3D text. Call this signifier. We can signify the score here. I'm going to turn it towards, ooh, no, not that, Control Z. Grab the signifier, turn it towards me, and move it forward. See, I can't see anything. This text is way far away. Let's move it forward. There we go. Why are you so far away, signifier? Okay, and let's make it much, much, much bigger. We can do that by changing the scale, but we can also change the font size. So we're going to do a little bit of both. I'm going to change the font size to 350. Ooh, nope, 150. There we go. That's nice. All right. It's a little off kilter. I can click this little rotate thing here and rotate it how I want it a little better. And it's still kind of small. We're going to do this super quick. This signifier is over score 5, so I'm going to call this one 5. I'm going to duplicate it, move this one over here. This one is, this game's going to be ugly. Sorry, it's going to be ugly. We're just working on something ugly. Okay, so pretty happens later. This is functionality I'm worried about. This one was 2. I know that because I labeled these what it did. We already did the math if you're just tuning in. So a lot of this is already done for us. So we're just labeling it. So we're going to go 2, right click and duplicate that again. Maybe I don't want these right there in the mess of things. Maybe I want them elsewhere. Ah, yeah, that's a good idea. I can kind of put them kind of a little bouncer there. Okay, so this one, if I go to the signifier right here in the corner, easiest way to grab them is not in the viewports. You can click on them here, but that's harder. Just go to what you're looking for. So this one, where I'm matching it up in order, so that one was 5. Wait. Is that all of them? So, yeah, okay, so 5, and then it goes in order here. So 2, -2. I don't think that's the case. Let me look. Let me select that little thing. So that one's 2. This one's 10. Okay, let me fix that. Sorry about that. Boom. Boom. There's nicer, neater ways you could do this. There's, again, you can get as complicated as you need to be. But for today, this is more than fine. So -2. So we're gonna go to signifier here, duplicate it, move it over. -2. And we're gonna duplicate this again, move it over. The last one should be 100. Why these scores? I'm just making ridiculous scoring just so we can see that it works. That's the only reason. All right. So now, if I hit play, let me select the screen. There we go. When I hit space, I drop a ball. No, my score is -2. It's -4. I suck at my own game. Two. The math just works. Why? Because all we're doing is adding the number we want to the score. It's very simple. And we're just displaying that live. It's just going, okay, what's that number it has there? Okay, that changed. I'm going to change the number on the widget. And man, I really suck at this. And I'm like kind of mad. I want it to be at least not negative. All right, so it goes to 1. This will play for infinity. So we could essentially put a win condition on it. But this has been going on for quite a while. If you guys are wanting a win condition, let me know in the chat. But I think we're going to package this up because we kind of got a nice little playable game. I'm going to add one more thing now. We're going to go to, unless, again, if you guys are willing, I'm willing. But let's see. To keep working on this is what I mean. So I'm going to add a button. So we didn't do a button yet. I'm going to add a button. No, we're not going to do a button today because there's no mouse, and then we have to expose the mouse, and actually that's going to be a mess. So not a mess. It's not hard to do. It's just not working well with this nice game design. We're going to add another text thing that says the instructions. I'm going to grab this in. We're going to put it maybe below the score. Call this instructions. We're just going to type out, press space to launch ball. press X to close game. Why? Because when we package it, there will be no way to close the game unless we do that. Let's see. What does this look like? That's a little annoying. There it is. Let's do that. Again, let's center it. Just gonna move it to the left here. Let's make it a little smaller. We can just, again, like PowerPoint, it's got all the same tools as PowerPoint, pretty much. If you've ever had to use something like that. Font, here we go, size, we're gonna make this 24. Anything smaller than 24, the player's not really gonna be able to read it. Here we go, our ugly little game that could. I am gonna move the pawn launch, this pawn start thing. Let me go to this arrows here so I can move it to the right just a little bit. Now I want it to the left just a little bit. All right, there we go. Ew. Ew. Do you see that peg? I'm sorry. I apologize. This is gross. This whole pegboard's really gross. But that's a little better. Okay. And then let's go to our green here. Let's make this less of a disgusting green at the very least. Okay. So we got our, I select this, we got our color. I can hit this little magnifying glass, it'll take us right to it. We made it earlier. Let's just make this a little less of a puke green. Sorry, had to look at that. All right. There we go. We got a game. Now, when we press X, it doesn't actually close the game. We need to fix that. Let's go to our player controller here. Right click. Okay, this can see, remember, the player controller can see our controls. Makes sense, right? We're going to hit event. We're going to type like event X. Why? Because I know that helps. Not why. The reason why is because I know this is an easy way to find it when you type in event X. Because it's an event for when X is pressed. Now we get the press and release for X. When we press X, we're going to quit game. It's that simple. This is a pre-made node. We're done. So now I'm going to hit play. Game started. I'm going to hit X. Sorry, once it's selected, I'm going to hit X. It closes. Space. Launches the balls. Oh, 10 points. And then X closes the application. Just like we promised the user. We have an app. We have an app. We could do rounds, we could do timers, we could do like game managers, we could do score switch ups, we could do we could add physics to the ball to make the ball bouncy, we could make it slick, we could add different types of pegs, we could make it to where the pegs break over time, we could go forever on stuff we could do. But I think we're getting to the point where we have a beginning to end holistic project here. So now we're going to go to the project settings. This is a very important thing. If we package the project right now, we would have everything under the sun in this thing. We don't need everything under the sun. We just need this one stupid level. So there's one trick to this. First off, just because we're already in here, it's a little different. But if we go to not the description. If we go to, man, I just had a big brain fart. The default maps and the maps and mode. That's it. I was already where I needed to be. That's why I was messing up. Okay, the default maps and maps mode. It's going to default to open world if we open this back up. So if you're working on this on your own and you want to keep it going, you're going to want this to default to the map we made, which is called Peg Machine Basic. Also, when the game opens up, if we package this game right now, it would open up to the wrong thing because it's going to open up to the open world thing that Unreal Engine 5 likes to open up to. We needed to open up to the level we made, Peg Machine Basic. Now, it will start the same way we started it when we just started it earlier in the editor. However, if we package it, we'd still get everything under the sun. So we're going to go to packaging. Why this is in advance, I don't know. I didn't make this thing. But for some reason, one of the most basic things you need to do is in the advance in the middle of a big pile of junk. Okay? But you're going to go to packaging in the corner, drop down advance, and you're going to go to list of maps to include in the package build. If it's 0, it will include everything. So we just need to add the one map we want. I'm going to hit plus. This creates an array of maps, right? I'm going to hit this. And in the content, I'm going to go inside Peg Machine in my maps folder and look at that. I got a basic.u map, a Peg Machine basic.u map. That's our map. Now, when I package the project, it will only include things that that map needs. The project size has gone down significantly. It will launch on that map. We just set it up. So now we're ready to go. We're ready to package. And it shouldn't take too long. So let's go ahead and do it. We go over here to platforms. We made a Windows device platform. Oftentimes you need the device you're working on, or you need some sort of a Gradle or something like for Android. That's a whole nother day. But today we're on a Windows machine, so we're going to package a Windows thing. Now, shipping, development, debug, what does that do? If we had left those print screens in, it would show those in a development build. A shipping build cuts out all the print screens. It cuts out all the development nodes. It's a little cleaner. A little cleaner, and actually certain things have to be a shipping build to get them on the store. So also the development build, you can access the Unreal Engine commands through like the command line when you hit comma. And a shipping build, it's actually like this is just your game. It's as clean as it can get. We're going to select a shipping build, and now that we've got that selected, when I hit package project, I'm going to make a new folder, and I'm going to call this, I always call it packs like that. I don't know why. I just do. It's a quirk of mine. I'm sorry. And I'm going to hit select. And then I'm going to hit show output log, because watching this makes me feel like a real programmer. And it's going to give me logs of everything going on and when it's packaging the project. When you package a project, it will also package the materials. And it will compile all the shaders that the project needs too. So the first time you package, or if you're doing a complete package, a full package, you need to change anything for any reason. If it decides it needs a new one, it will do the whole thing. But for the most part, when you package, the first one's going to be the longest. And then as long as it doesn't have to throw everything out and restart for whatever reason, most of your packages will be a lot shorter after your first package. This package shouldn't take too long because I got a decently powerful computer, and it's compiling all the code into something that can be ran on a standalone application. Getting rid of the editor, getting rid of all the junk it doesn't need, just only loading that map and what it needs to run that map. Which is so surprising, a lot of things. But you can see right there, look, basic color map. That's our material, right? And these things are some things that are endemic to the engine and how the engine works and things like that. So there's always going to be some bloat unless you really go in there and clean it out, which you're probably not going to have to do ever, because by the time you're working on a game that's that important that you need to get into the nitty gritty, you're not going to be worried about that 0.2 gigs unless you're trying to get it like to package on a QR code or something crazy like that. But for an Unreal Engine game, we're probably never going to have to do that. Any questions while you got me here before we test this out about anything we did or anything we didn't do? Like how would you make it to where the pegs disappeared, or how would you make it to where we had levels or whatever, new levels? You can ask me. So I plan on doing more of these live streams over time. I don't know how consistent I'm going to be right now, but I do hope to be fairly consistent. And I may cut these eventually into shorter versions that can be found on the channel. But the reason to do it as a live stream as a long format is because I like the incidental teaching that goes on with doing it holistically. I don't like the way the tutorials are done most of the time, where they do something really complicated. They're like, let's make League of Legends, and then it's like 15 tutorials, and they get really specific, and they don't even really know what they're doing half the time, and they bake in some problems, and they like, it's just a long, complicated mess. I thought it'd be helpful if we did something where we had a small, basic idea, where we did sometimes we reach and we do some of the fancier things because we have time, but sometimes we just do it as simple, where we teach how these things talk to each other, how the engine loads, what it's looking for, how to package it correctly. And so once you get these basics down by following along on some of these one night builds, putting these concepts together and building something bigger and more complicated is going to be a cinch. That's my hope. That's my hope in doing this series. And I thought too, it doesn't matter if you can't package it; it's not a game, right? If you can't package it, it's just something to show off in the editor. So I want to like start from scratch. I might have the shaders precompiled next time, but I'm going to start from scratch. We're going to pick a simple, basic concept, build a game for it, which includes the widgets, the materials, the physics, the spawning, the player controller, the everything. And again, we started with a blank level, right? Starting with a template is a good way to get started when you don't know what you're doing, but starting with a template can really hamper you because it really locks you into how that epic designer was thinking about their game. But that's not necessarily how games work. It's actually a lot simpler than those templates can make it sometimes. Those templates can lock you into some bad habits. Sometimes I don't like some of the ways they build those templates. The VR template, for example, had everything. Actually, I really like the old VR template. The new VR template's a little too bloated, where you have to kind of like build a little subsystems to work with it. It's like it's not bloated enough, and it's also too bloated. It's like if you could just either dive in all the way. I don't know. I could talk about what I don't like about it all day, but it was easier to make VR apps in Unreal Engine 4. I will tell you that. Now it's nicer to make VR apps in 5, but it's easier in 4. But 4 doesn't really keep up with the stuff you need anymore with all the fancy new packages and plugins for Oculus and stuff like that. So, but it was just a simpler layout. You could abstract it a lot easier. Less tools are sometimes better. All right, we should almost be done packaging. Sorry it was puke green for a while. I'm not a designer. I don't make things pretty. I think I can make things fun. But I don't necessarily make things pretty. This game's so simple, I can play it while we watch. Okay, gonna hit X close. I'm gonna show you something too. One thing you can do is you can view the frames per second. Because this game's so simple with such simple materials and everything, even while packaging, I bet the frames per second will be high. Ah, they're actually kind of low. I'll tell you the main reason they're low, on only 30 to 40 frames a second is because I'm packaging. My CPU is busy. This is how it runs right now in the editor with everything open, with this open and this open and this open, and thinking about like all that in my memory and thinking about this material and rendering this collision on this sphere we made. You know, all this stuff is running. When you're checking, this is a cursory way to check the performance of your game, but it's not actually a reliable way to check the performance of your game. That's a whole nother like um, profiling is a whole nother day to go into. But it's a quick cursory way. If this is high, you're good. If it's low, oh. But the reason it's low right now is 100% because I'm packaging. If I wasn't packaging, it wouldn't be running at 40. It'd be running probably at 120. Let's let's spawn. Let's spawn them. Let's exploit it. Oh yeah, my score's overlapping now. So I could actually build those in a way that it won't do that. If I wasn't packaging, I would. Let's go ahead and I'll show you. I'll show you while you're waiting on me. Let's go to blueprints. Let's go to our widget. If I added a horizontal box, this is essentially a formatting tool. And I can put the text inside of the horizontal box and this inside of the horizontal box. Wait, I gotta drag them and like touch it to it. It's not doing it. There we go. There we go. It's not doing it. I don't know why it wasn't for a second, but okay. So see now, these things are auto formatted in this horizontal box to be next to each other, and we can add padding to it. That where they keep a space in between. But this will actually make it to where they scale apart from each other, so they stay separate. They don't overlap. Keeps things. You can make nice grids. Keep your buttons in grids. Very useful thing. Um, let's see if it fixes our problem. I changed that while packaging. It probably won't make it to the package. Just so you know, it's gonna be running off its like cached stuff. So if I wanted this change to be, yeah, see how it's staying separate now. If I wanted that change to be in the actual package, I would have had to do it before I packaged. Much better though. There we go. All right. Let's see. X quit. Go to the output log. See what's going on. Still packaging. Again, the first package, the first cut's the deepest, and the first package is the longest. Hmm. Thank you guys for watching. I can tell a lot of people tuned in for different parts. I'm pretty excited about that. let's see how this ages on YouTube if people are enjoying the one night builds. Sadly, uh, it's not super fun to to watch it package, but I just something about the pureness of starting from nothing and packaging. Like not having a packaged version means you don't have a game, right? I want us to end every night we do this. I want us to have a game. Um, Maybe I'll have a faster computer soon. I'll package it a little faster next time. But it shouldn't be much longer. It's looking like we're getting to the end here. 29 remain. So it is using Lumen by default. That's another reason why it's a little lower frame rate. Lumen is expensive. Now, it's limitedly expensive. If you did what Lumen does without Lumen, it would be crazy expensive. It certainly has much less overhead for the amount of light you're getting when you do Lumen, the amount of bounce light and stuff. It's beautiful. It's amazing how much it can do for Lumen, for what it's doing. But that being said, it's not using a forward renderer. It's not using the simplest version of a light rendering, geometry rendering engine. You can change the renderer in Unreal, and you can get for a game like this. If we did forward rendering with only one light source, forward rendering and one light source go beautifully together. This is using deferred rendering. Using deferred rendering can limit the amount of like when you add light sources, it limits the damage that light sources can cause to your game's playability. Um, we are using a deferred renderer, which is actually a little heavy for the beauty we're looking for here. It would still be a little prettier than if we just did forward rendering without Lumen. Um, but we could really this very simple game, we could really make it super super efficient if we moved to forward rendering, which is what I would do if we were. Um, that's here in the project settings, just to give you some more information. If you go to rendering, um, right now we have global illumination set as lumen. We'd have to reboot it to do it differently, but you could go to none, I believe, and then you could change the type of rendering. Right now, we're not using forward renderer, but we could do it. We could go uh, forward shading, um, and that would render it to where it renders per light source, so it doesn't break it up into frames and defer the rendering into different frames of different layers like a deferred renderer does. It would render everything at once based off the amount of light sources. That's a rough. That's kind of a bad way of explaining it, but that should be a little bit helpful. So if you don't have that many light sources, and if you have a very simple scene like this, forward rendering's faster. But deferred rendering is usually faster once you start getting some bloat. It has some bloat with a deferred renderer that stays there, but also limits how much it bloats. The bloat helps reduce bloat. That's a way. That's a good way to think of a deferred renderer. It's bloated, but it helps reduce bloat when you have a bloated amount of light sources and stuff and shaders and things. Deferred renderer can help with that too. But this is so basic. I just heard the chirp. Did you hear the chirp? That chirp means it's done and it completed successfully. Look at that. All right, let's see what it runs at now. Oh, it's still only 40. Huh. Again, that's because of Lumen and the deferred renderer. We could make it faster if we needed to, but 30 to 40 frames a second is fine. It'll run a little faster standalone too. So I'm going to save it, close this out, and then I'm going to. I know my version of Windows is weird. We talked about it at the beginning of the stream. Uh, I gotta remember the file it's in. I remember what file it's in. It's in my F drive, and aha, yes, in Peg Machine. Here we go. So I put it in packs. So I close the editor out now. And this is this Windows package. If we did other kinds of packages, it would put them here. Inside the Windows package, we have pegmachine.exe. Let's run it. All right. Once everything loaded up, it started working. So yeah, we could hide loading, right? That's what that was. When it popped in like that, it was loading. Uh, it was loading a material. It was like there, the mesh was there, but the material wasn't there. We could hide loading with the loading screen where you just have cover it up with a widget. That's all a loading screen is. It's a widget that covers it up, and you just decide when to stop covering it up. Um, in most cases. Boom. Boom. And then it doesn't have our pretty score formatting because I added that after I decided to package, so it's going to overlap. But I showed you how to do it. I showed you how to fix that problem. So if you repackage now, it would go faster and it would have the right score that wouldn't overlap on itself like that. So I'm going to hit X to quit because if you notice, there's no way to quit. I don't see my mouse. I don't have any way to quit. I'd have to like Control Delete do taskbar or something. So I'm going to hit X. It closed like we told it to. We did it. That's a game. That is a game. A checklist. A checklist is something I could do. I could do again. So I kind of invented this as we went, just based off time, how fast it was going. Because I was kind of doing kind of an on the fly what I do in my basic process of building a simple game, and kind of explaining the whys as I go. But a checklist is a good idea. So I can kind of come up with some things that we're going to do. Like we're going to need at least A, B, and C, and kind of go through that. For this game, um, we made some level design stuff, like some actors that we could move inside the level to customize it per the level, some exposed variables that we could customize speeds and stuff per the level. We did some material, a little bit of material work. We did a little bit of collision work, like we made some custom collisions. Just as needed as things came up, we tackled it. So yeah, so we just finished, but the stream will be up forever, and eventually I might cut it to be a shorter version that has a little less weighting on packaging and stuff like that. But yeah. Any more questions? Because I'm about done for the night, but I think this was a lot of fun. I think I'm going to do it again soon. Thank you guys for tuning in. I actually kind of expected to talk to no one tonight, but I had quite a few people come in and hang out for a minute, so pretty thankful for that. And I hope you found it helpful. Again, I've been doing this for 6 years now. I hobbled along those first few years. I wasn't very good, but now I've been doing it professionally for a while. Working with Third Pie Studio on a game called Kataria, Ages of Kataria, and that's coming out in September. And I should probably be working on that right now, but I decided to take a little break. So thanks for joining us. Yeah. Any more questions? I'll give you a few more seconds before we end it. I'm gonna end it with some Peg Machine. All right, you guys have been awesome. Thanks so much. I will see y'all next time.